Students, we are given this question. We are expected to evaluate integral 0 to 2a x squared times square root of 2ax negative x squared times dx. So I would make the substitution x to be equal to 2a times cos squared theta. Now if you differentiate this, you get dx is equal to 2a times differential of cos squared theta is going to be 2 times cos theta times differential of cos theta. So that is equal to 2 times with 2a would give you 4 times a cos theta times differential of cos theta is sin theta with a negative sign. So you now have negative 4 times a cos theta sin theta. Of course you need to place d theta. Okay, so we now got dx, we have x, so now we need to take care of the limits. So when x is equal to 0, you get 0 is equal to 2 times a cos squared theta. So this means cos squared theta is equal to 0. Now what value of theta will you place to get 0? Clearly theta should be pi over 2. So we have got the limits theta to be as pi over 2. We can box that. Next, when x is equal to 2a, so that would mean 2a is equal to 2a times cos squared theta. So 2a gets cancelled. You get 1 is equal to cos squared theta. What value of theta will you place to get 1? Clearly theta is equal to 0. So in this case you have got theta to be equal to 0. So the limits are settled. So therefore integral 0 to 2a x squared times square root of 2ax negative x squared times dx can now be rewritten as integral, in the place of 0, when x is equal to 0 you got pi over 2, and when x is equal to 2a you got theta is equal to 0. So this has to be placed. Now x is 2a cos squared theta raised to the power 2 times root of 2a times x is 2a times cos squared theta negative, again x is 2a times cos squared theta raised to the power 2 times d theta is negative 4a times cos theta times sin theta times d theta. Okay, this is what you get. Now rewriting this, I can take the negative sign, rewrite it as integral pi over 2 to 0 2 times a cos squared theta raised to the power 2 root of 2 times a times 2a. That's going to be 4a squared cos squared theta negative, square this up, you get 4a squared cos to the power 4 theta times, this is going to be cos theta sin theta times d theta. You get a 4a there. I'm going to place the 4a in parenthesis, so the square root ends here. So this can be rewritten. Actually I got a negative sign, so I can flip the limits as 0 to pi over 2. I expand this, I get 4a squared cos to the power 4 theta root of 4a squared can be taken out common. In fact I can also take out cos squared theta common, so that would give me 1 negative cos to the power 2 theta, okay, times I got a 4a, I place the 4a here, and I got cos theta sin theta times d theta. Now this can be rewritten 4 times a times 4a squared, that's going to be 16a power 3 cos to the power 4 theta. Now I take this root, I write it as root of 4a squared times square root of, now this is actually cos squared theta, root of 1 negative cos squared theta will give me sin squared theta, times cos theta sin theta times d theta. Now root of 4a squared is going to be 2a, has to be multiplied with 16a cubed, integrated with integral 0 to pi over 2 cos to the power 4 theta. This is going to be root of cos squared theta times root of sin squared theta times cos theta sin theta times d theta. Now this is equal to 32a to the power, a cubed with a will give you a power 4, integral 0 to pi over 2 cos to the power 4 theta. I have a root of cos squared theta, that will give me cos theta, root of sin squared theta, that will give me sin theta, and cos theta sin theta times d theta. Now this can be multiplied with this, so that would give me cos to the power 6 theta. Sin and sin can be multiplied, giving me sin squared theta with 32a power 4, and this has to be integrated between 0 to pi over 2. Now we have already studied the reduction formula. What is the reduction formula? I'm going to write it down here. We know that integral 0 to pi over 2 sine raised to the power mx cos raised to the power nx dx. Now when m is even and n is even, we started off writing it as n negative 1 divided by m plus n times n negative 3 divided by m plus n negative 2, n negative 5 divided by m plus n negative 4, plus etc. We ended with 1 divided by m positive 2, and this has to be multiplied with m negative 1 divided by m times m negative 3 divided by m negative 2, m negative 5 divided by m negative 4, etc. We ended with 1 over 2 times pi over 2, right? So this is the formula. So if we were to apply this formula to this, my m is 2 and my n is 6. So I'm going to apply starting with 6 negative 1 divided by 2 positive 6 times 6 negative 3 divided by 2 positive 6 negative 2, 6 negative 5 divided by 2 positive 6 negative 4. I can't go further, I got to stop here. Followed by m, which is going to be 2 negative 1 divided by 2. It has to stop because the next term is m negative 3, can't apply, and I have to end with pi over 2. Okay, so rewriting, so that whole thing has to be multiplied with 32a power 4. Okay, so this is equal to 32a to the power 4. 6 negative 1 is 5, 2 positive 6 is 8 times 6 negative 3 is 3. 2 and 2 gets cancelled, giving you 6. 6 negative 5 is 1. 2 positive 6, 8, 8 negative 4 will give me 4. Okay, that has to be multiplied with 2 negative 1 is 1 divided by 2 times pi over 2. So can we cancel anything? No. So this is going to be just cancelled against 32. Now 8 divides 32 4 times. Now the 4 and the 4 can be cancelled, giving me an answer 5 times 3, 15 pi divided by 6 times 2, 12. 12 times 2 is 24. So this is what we have got as the output for this question. Of course, we should not forget this a to the power 4. So place that a power 4. So rewriting this is going to be 15 pi a power 4 divided by 24, which is the answer to this question.